Thank you everyone for joining this workshop today. As it says in the slide, we are all here to look at the ADAPT workshop, which is a competition on advanced agile production as part of the metrics projects, which will all be explained in these presentations today. Let's see if my slides move. Yes. So let me first start with a welcome and an introduction of who we are and what we are part of. And then I'll present the agenda and we can start the workshop. So hello, my name is Roel Pieters. I'm from Tampere University. The other people that are organizing this workshop today are Max Pfingsthorn from OFFIS in Germany, Pierre Lunis from Proxinov in France, and Farzam Ranjbaran and Jaunari Rabarari Zoa from France as well. Of course, many other people have also contributed to this workshop, but there would be too many to mention. We organize this today as part of the metrics project, which is a project funded by the European Commission, which has the title Metrological Evaluation and Testing of Robots in International Competitions. And we will go into some more details of this in the next presentation. What we are doing today, this workshop, is about the ADAPT competition, where ADAPT stands for Advanced Agile Production. Feel free to use Twitter if you want to put this on social media. And of course, all information you can find on the metrics website that you see in the link below. So about today, this is the schedule, this is the agenda. I'm now busy with welcome and introduction. After this, we will have Guillaume Avrin from LNE give an introduction on the metrics competition, and Guillaume is the coordinator of the metrics project, sorry. Then I'll give some details about the competition itself, a bit more high level, and then Max and Farzam will give some details on the field campaign and the Cascade campaign, which are two parts of this ADAPT competition. Then finally, we will try to close the day with some open discussion on the competition if there's open questions, or we will have a discussion on different topics that involve it. If there's any questions, please feel free to ask me via the chat. At the moment, I cannot see the chat, so if they're pressing, then of course, feel free to speak out. But of course, the other organizers, they can also just interrupt at any time. Any questions at this moment? If not, then I will move to the first presentation, which is from Guillaume Avrin. I will have to reshare my screen because he is not physically present in this meeting, but he sent a video that we could show, which I will now do. And please, if it does not work, please let me know. First, a brief introduction. Guillaume is the coordinator of the metrics project, and he is part of LNE in France, which is the National Laboratory of Metrology and Testing. He is head of evaluation in the AI department, and since 2017, he has been in charge there. For this, he organizes or he coordinates a team of engineers and researchers, and they work on the definition of evaluation protocols, metrics, and testing facilities, all for AI and robotic systems. Besides this, he also participates in standardization committees and is involved in different projects internationally and in France as well. So let me now start his presentation.
Hello everyone, thank you very much for participating to this presentation. My name is Guillaume Avrin. I'm head of the evaluation in AI department at LNE, the French National Laboratory for Metrology and Testing, and I'm also coordinator of the H2020 metrics project, which will be the focus of this presentation. The basic observation that is driving the metrics project is that there is a real need to evaluate AI and robotics technologies in order to bring the supply of such systems closer to the demand. Because we know that suppliers and equipment manufacturers are providing black box, sometimes non-convex, evolutive intelligent systems, whereas end users are looking for trustworthy and efficient functionalities. So there is a need for end users to be able to choose between different technologies that are entering the market, to benchmark them with reliable measurements of their performances in order to select the best solution for their companies. And for suppliers, there is a need for third-party testing and conformity assessment to improve these technologies and drive R&D efforts. So one of the main objectives behind the metrics paradigm is to make sure that robotics competition are more than one of demonstration and adopt the form of repeatable and reproducible scientific experiment based on methodological principles. Thus, the first step of the project is to develop such an evaluation methodology, capitalizing on the consortium past experience, providing a rigorous and quantitative evaluation of intelligence system. Second, the reliability and validity of AI algorithms are at the heart of European concerns. This requires the competition to address both the behavior of the robot and the behavior of its AI algorithm. So the metrics is combining robotics and AI competition to mobilize both communities and to develop smarter and safer robots. Finally, our priority is to make this competition relevant to the needs of the industry and to maximize the take-up by the European AI and robotics communities. The project is collaborating with digital innovation hubs, clusters, and external sponsors. To carry out this project, Metrics brings together 17 European organizations specialized in the evaluation of artificial intelligence system and robotics system, and the main European player in the organization of robotics competitions such as Chirog, RoboCup, Rose Challenge, and so on. An advisory board, including the NIST, the National Institute of Standards and Technology from the US, and the Queensland University of Technology from Australia, as well as a robotics stakeholder boards of more than 10 members, are ensuring the sustainability of the initiative beyond the 3 years of the project. Regarding the organization of the evaluation campaign, each competition will last 3 years with 1 dry run and 2 official evaluation campaigns, so as to estimate the technological progress through the competition and provide short development and test loops. The evaluation method used to evaluate the performance of an intelligent system, be it a complete robot or specific algorithms, is always the same. It involves comparing the output of the system being evaluated, their prediction or behavior, with reference responses defined by human experts. And metrics are used, which are mathematical formulas, are used to quantify the difference between the output of the intelligent system that is evaluated and the reference response from the expert in order to measure the performance. So each metric competition includes functionality and task benchmark. The task benchmark investigates the performance of a robot system when executing a given task, for example, to fetch for a glass of water when asked by a human. The execution of the task therefore requires the use of several functionalities of the robots. And the functionality benchmark investigates the performance of a robot component when executing a given functionality, meaning a unit of capability that is too low level to be useful on its own to reach a goal, for example, to understand the fetching order, to detect obstacles, and so on. This breakdown of benchmark addresses the evaluation need of end users, integrators, equipment manufacturers, allowing both to verify the overall performance of the robot and to identify the technological parts to be improved. For each competition, Metrics is organizing both evaluation campaigns in physical environments with physical test beds targeting the robotics community, and evaluation campaign based on testing datasets called Cascade evaluation campaign and targeting the AI community. The datasets used during the Cascade evaluation campaigns are produced by the robots participating to the field evaluation campaign, for example, images for object recognition. Thus, each Cascade evaluation campaign is interspaced between 2 physical environment evaluation campaigns. Thus, the 4 metrics competitions are implementing this common evaluation framework. However, the task benchmark and functionality benchmarks that are considered are different between the different competitions. The HealthMed competition, for example, in the health area, is focusing on assistive robots, whereas the RAMI competition in inspection and maintenance of infrastructure is considering expedition autonomous robots with an underwater track and aerial track. The ACRE competition in agri-food is evaluating weeding robots, and the ADEPT competition in agile production area is considering collaborative assembly robots. So how to get involved in metrics competition? Well, you can do it as a participant. What does it mean? It means that you can register to the competition you are interested in by sending an email to the organizers, and you will have access free of charge to the evaluation tools made available by the consortium during the evaluation campaign. It will allow you to have your system evaluated by trusted third parties and to position this technology in relation to the one of the other participants and to set up new collaborations. You can also be involved as a sponsor. It means that you will help us drive the competition through sponsorship with cash or in-kind contributions, and to define the evaluation criteria and testing scenario so that you make sure that this competition and evaluation campaign are relevant to your business current and future needs. To do so, you just have to send an email to the Metrics Consortium. So thank you very much for your attention, and don't hesitate if you have any question.
All right. Thank you, Guillaume. I hope this was all audible and visible for you as participants. I will switch back to my slides. Let's see. Regarding this metrics introduction, are there any questions? Perhaps one thing that I can mention myself is that it's of course a very high-level overview, and there's 4 different competitions, and the different competitions run at different times, but you can find all this information on the website. And as far as I now know, is that 2 other competitions also already had their first workshop. So the videos of those, they're also uploaded to the website, or they're linked to the YouTube channel, so you can watch them as well to get an overview of what their competitions are about. Okay, I will move on then to the ADEPT competition that we are currently organizing now, and which we are presenting today. And I will move then to the next slides to do that. So let me start first with a rather long sentence. So in this long sentence, we sort of sum up what this competition is about. So the ADEPT competition aims at addressing typical dexterous manipulation tasks of industrial components and involved in intuitive multi-modal interfaces and human communication channels, all to assemble an industrial mechanical system. So there's many keywords here, but the main topics that we will focus on is collaborative robots, computer vision and AI, to the industrial use case, let's say, for agile production assembly. One sort of particular example that you can see on the bottom right in the image is a collaborative robot that is being hand-guided to do certain tasks. And this is something that we focus on as well in the competition. This competition, as mentioned earlier, runs for 3 years. And in each year there is 2 competitions. One is a field campaign and one is a Cascade campaign. The field campaign, they're physical, so teams can meet in labs to actually do physical competitions with real robots, and these are open to the public. Anyone can join these. And Cascade campaigns, on the other hand, they are online and they are with data. And what this data is, this will be explained in the later presentation. But the things we focus on is benchmarking for both perception and for human-robot interaction. So the Cascade campaign and the functionality benchmarks, they are on perception, the detection, the pose estimation of objects and parts, and the quality control of assemblies. And in the case of human-robot interaction, this is more towards the task benchmarks, and these regard collaborative robot programming and coordination between a human and a robot. This is in some bigger lines, the competition itself. And of course, we will go in more detail in the next presentation. The tentative schedule for this competition can be seen in this diagram. So 2 dry run campaigns and 2 field cascade campaigns will be organized. A dry run campaign is to test our developments and to test the competition, and this is something that is happening currently at the moment. We are right now in the Q1 of 2021, where we are doing our field campaign dry run. So this means that we are testing the things we developed, test the competition and the evaluation plan. And then after this, in Q2, we will start the dry run for the Cascade campaign, which is then the online competition on the data collected during the field campaign. And this is something that is going to happen soon. And again, we will hear more in the next presentation. Then in 2022, in the beginning, we will have the first field campaign, and then again after that, the first Cascade campaign. And these are a bit different from the dry runs, as in the dry runs we test our things, and if there's things to fine tune and to develop further, we will do that. And then the first field and Cascade campaign should run with teams that join more professionally. And then again in 2023, we will have another round of field and Cascade campaigns. The exact dates of these, they will of course be communicated further and on the website, and most likely there will be again workshops to introduce this better and to introduce the changes and the competitions itself in the future. Then on the challenges, as I mentioned earlier, these are divided into functionality and task benchmarks. I will not go further into detail of this, as this will be explained later on, but the parts and the robots itself, they are here depicted in these images, that these are something that you can expect. So for the Adapt Field campaign, this goes for the competition is held for both the functionality benchmarks and the task benchmarks. So these are both considered. There's now 2 task marks selected. They will be improved over the years, of course, and they will also be considered to be extended. So there could be more task benchmarks, or they could be changed. And the first field campaign for this will be in the beginning of next year. Then the Cascade campaign is only on functionality benchmarks, on perception. And again, they will be continuously adapted, so that if you can participate 1 year, the year after that, it's assumed that, you have had more time to develop things, so that the challenges should also be adapted a little bit. And again, as I said, in the first Cascade campaign should be coming in a few months as well. For this competition, there's a few test beds that are open to be used. You can see these here in the 2 figures. Both OFFIS in Oldenburg, Germany, and Tampere University, we offer our labs that people can utilize. They are quite standard collaborative robots, and there is no restrictions on which robots you can use for the competition. But we have replicated the same setups in both labs, such that the competitions can be tried out there as well. Besides these physical test beds, we are also working on simulation, where the robots and the parts can also be tried and tested in the simulation environment. And this is something that should come openly available soon as well. Then there are several ways to actually join the competition. First of all, this is to join as a team. This is very broad as well. We offer, or we don't limit much about who can join as a team. So this can be, for example, a student team or a hobby team that is interested in robotics or interested in computer vision and perception. So either as part of a university or not, that doesn't really matter. and also as part of a research center or research institute, which can have the same interests. Then third, which is also very interesting, I think, as a SME developing systems that could be utilized in the competition. So if you have a camera or a processing unit or robots that you develop, and you would like to test them on our competition, on our benchmarks, that's of course very nice to do as well. And this is possible. Why would you do this? Well, you will get recognition and exposure to you and your developments. So both as a student or as an SME, the things you do will become public and people can see it. Besides this, you can win awards and badges. So this is something that you can use on your CV and which helps you in your career, for example. And as a company, it's very nice to demonstrate your solution, or as a student team or a research institute to demonstrate your research. Because we believe that the challenges that we set, they are quite interesting for a broad public. Then secondly, you can also join ADAPT as a sponsor or as a stakeholder. And this is, of course, also a very broad statement, but there are several ways to do this. So you can either support the organization of benchmarking in Agile production. You can decide which competitions or which challenges you would like to see by providing the challenge. And in return, you get access to results and in access to talent. You can see people developing your solutions and developing things for your challenge. So how would you do this? You would sponsor either a team, an award, or a prize, or you could sponsor an event. And there's different options. And of course, this is something that has to be agreed upon, which is the best way forward. So in that case, we of course advise to contact us so we can discuss further. Any more information on this will be updated on the website that we have made. On that, you can also find the latest version of the evaluation plan, which has the latest information on all the descriptions of the benchmarks and the metrics of how we evaluate them, and the competition as well. And of course, you can send us emails to ask questions or to communicate your interest in joining or in sponsoring. That was my higher level presentation of the competition. Are there any questions at this point?
Yes. Hello.
Hello.
This is Damun. I'm approved PhD student from Tampere University. I do have a question. First, are we going to have your slides or any other slides so you can look further into them?
Yes. So I will provide these slides both to the participants and also on the website. And I'm also recording these videos, so we will put this video also for people to see. So yes, we will provide it.
Okay, thank you. And I have another question that is the evaluation for students and research institutes and the other ones are going to be the same, like given that probably they have different equipment and opportunities available to them, or is evaluation is going to be the same for everyone?
Very good question. So the metrics and the tools we use for evaluation, they are the same, correct? But most likely there will be different awards for different tracks. So I can imagine that the student teams would participate in a different track than, for example, an SME, which has more resources available, of course. So in that case, we will make sure that there's different tracks for awards to be given out. Of course, this is something that we have to think about a bit more carefully. So it's a very, very good point.
Okay, thanks.
Is there anyone who wants to comment on this as well, on this last question? All right, not at this point. Of course, the complete explanation of the awards will be made more clear as well. And then again, there's also a difference between the two campaigns. So naturally, the Cascade campaign and the field campaign, they're different. So the way things are evaluated, they're also a bit different. But they should become more clear in the next presentations. So if no further questions, then I suggest to move to the next presentation. I will stop sharing and I will give Max co-host rights so that you can share your screen.
Great, thank you.
And then let me quickly introduce you as well with the limited information that I have. But yes, welcome Max Pfingsthorn, who is a group leader in the Human Robot Collaboration Group at OFFIS. And OFFIS is the Institute for Information Technology in Oldenburg, Germany. And Max is already part of OFFIS since 2017, and he has a lot of history, or a long history in different kind of projects, both in EU and also in Germany, in German research projects. And he will present here today the ADAPT field campaign.
Yes, thank you very much for the introduction. At OFFIS, I work in the division production. So we have a own research division on production, manufacturing, digitalization, let's say. Well, my group obviously focuses on robotics. We have two others. One focuses more on embedded control systems and distributed control, and one that focuses more on the management of operation around production processes. So it's quite an important topic for us. That's what I mean to say. So I'm very happy to be part of this project. As Roel mentioned, I do have quite a long history with competitions. I think I started first year in bachelor's with RoboCup. So I'm also a big fan of this kind of format to drive innovation that maybe regular research projects cannot really do. It's much more broad like this. Okay, so roughly in time, good, fast. So basically, I will talk about the field campaign. The field campaign is, as Roel mentioned, the physical competition, meaning that teams and participants will meet physically and use a physical robot to perform their tasks. We did think about a remote participation option, though that's not really discussed very broadly yet. We do have kind of reference hardware available at both locations in Tampere and also in Oldenburg. So that would be possible, but it's not yet clear how exactly to phrase to what the requirements would be for the participation code. The idea behind the field campaign is to really be quite open in terms of solutions. So we broadly give a range in which we conduct the benchmarking, but within that, the participants are very free to design their own robots, put together their own system, robots and sensors and different grippers. And the idea really here is to be very open. And we have a few constraints that we expect just because of, let's say, practical reasons. One being a maximum physical extent of the robot. So this is footprint on the floor. It should fit through doors, so we can actually move it about. It's of course the team's responsibility to actually transport it to the competition site. But other than that, of course, we need to move it around to free up the competition area then for other teams. So that's why we said it has to be at most 0.7 meters by 1 meter footprint, so it fits through standard doors, also in terms of height, of course. This is the 70 centimeters width. And it shouldn't be heavier than 100 kilos. And if it weighs more than 30 kilos, it should have wheels, so we can push it around. And it should have a single 220 to 30 volts power connection. Other than that, there's of course some kind of minimum number of components that we would expect, though of course we'd like to be surprised by the teams there as well, which for us includes a manipulator, no matter how many degrees of freedom, and a corresponding gripper, as well as a calibrated camera of some sort, because we have phrased our challenges in a very, well, optically centered way, right? So we have our functional benchmarks that mainly look at object classification, detection, and localization. And to power the Cascade competition that we already talked about briefly, the idea is that participants will submit their data that they collect during the competition in the field campaign to then donate that basically to the Cascade competition. So that's how we would build over time a very rich and hopefully also diverse, because the participants will hopefully come with a wide range of sensors and robot kinematics. So we build a very diverse data set for this field. So one thing I skipped over in the previous slide was that the field campaign actually then consists of two parts. We would have an on-site version of the functional benchmarks that are then kind of mirrored in the Cascade campaign, and also perform the task benchmarks that are, of course, difficult to do if you don't have a robot, but we'll get to that in a bit. Quick overview of the functional benchmarks. We have defined 3 of them, one being detection and classification of the parts of the assembly. This could include screws, wheels, gears, pegs, and so on. So this will be a rather broad category. Some of them will be standard items, like an M5 screw, for example, Phillips head or hex head or something like that. But some of them will be also very assembly specific, like, for example, the specific kind of gear that is needed for this assembly. The second one is pose estimation, and here we really focus on precise localization, including possible rotational symmetries, especially for gears. You have this kind of discrete orientations that you cannot really tell apart, but this might be important for grasping, or at least placing it in the assembly, right? You need to place 2 gears next to each other so that the teeth interlock. It's very important to have this small accuracy there. But of course, within the symmetry, it doesn't matter how it's positioned. Also the same for screws, right? There's a rotational symmetry, for example, for the screw head, which is kind of discrete. So again, we have maybe a hex screw head, and then there are 6 possible ways to where you cannot tell the object, the rotation apart anymore. So this is an important feature, I think, of this functional benchmark, that these symmetries are especially included. For the third benchmark, we look at quality control, which means that we want to classify if there are any anomalies in the assembly that is shown. So we prepare partially assembled, wrongly assembled, and correctly assembled pieces that then have to be evaluated by the team. The task benchmarks focus, as I said, more on the, let's say, integrated view, right? So Roel mentioned the collaborative programming, which in my understanding really focuses on being able to semi-automate a process quickly. So how quick can we collaboratively convey the assembly task to the robot system, and how fast can we kind of kickstart this collaborative assembly, right? But he would rather use simple assemblies, so this can actually be done within the time limit of our competition. The other benchmark, the task benchmark 2, focuses on the assembly of complex parts. So here, really the collaboration with the robot is in focus. How do we perform? So how do we put our robot to good use, right? And quickly. So this may, while in task benchmark 1, this would be a novel assembly that the team has never seen before and has to then kick off their assembly process. In 2, it would make sense to have the assembly ready beforehand, and then really look at how efficient this collaboration can really be. And because it's a complex assembly, we would expect the robot not to be able to do everything, right? That especially in the collaboration, in this synergy between the human and the robot assembling this part together in the most efficient way, without either one being able to do it either as quickly or at all. And what this would look like. So we have a deeper look into the benchmarks now. The function benchmark 1, as I said, is about classification, knowing what object is in view. Maybe there will be multiple. On the right, there is a example of our data collection. Here we have a 3D printed marker as a reference, and the RGBD camera there on the Franca is looking straight at the items, and the expected outcome that we would expect from teams is to report a bounding box on in the table coordinate system, where which object is, and also for each bounding box report the class. I will not get into too much detail here because I think will be much more elaborated on in the discussion of the Cascade campaign, because these are comparable benchmarks. But I wanted to stress that in the field campaign, we would really focus on the evaluation of the team, right? So in presence, let's say, we would maybe not have such a highly automated system of evaluation as we would then for the Cascade campaign, but we would have a much higher variance, I think, of data. So in the Cascade campaign, there will be a rather fixed data set, right, for training and then for testing. Here, because we're present in the scene, right, we can move things around and test things out, and then have the chance to actually, because we're kind of doing synchronously, double check with the person if the result of the team is correct. Yeah. So same for the pose estimation, of course. Here I have a little example of what might happen with one of the gears. So on here, they were all nicely in a grid for data recording, but here, of course, one of the gears might be standing on the side, right? So this is something that is, of course, important for grasping and has to be detected properly. We would expect that the team outputs the 60 pose, so which means rotation and position in space, in table space again, of the object reference coordinate system, right? So we will define in relation to each of the CAD models that we provide of these sub-assemblies, reference coordinate system, and describe the rotational symmetries if there are any, so this can be taken into account. And this reference coordinate system has to be then localized in the work area. For the final functional benchmark, we're looking at quality control. So this is an image I think Roel has shown you before, but this is also an example of a partially assembled piece. Yes, so we have here this complex assembly. The planetary part of the gear is assembled, but it's not assembled already into the casing with the sun gear. So this would be an example of an incomplete assembly, right? And so according to this theme here, with we will classify a certain assembly as successfully assembled, faultily assembled. For example, if the wrong gear was mounted on the planetary head here, for example, if the sun gear was mounted here, that would be wrong. So it would have to be detected, or if it's just incomplete. And then also estimate the level of completion. For example, here we might say that for the sun part, we have 3 sub-assemblies assembled properly together. So there's the motor, the stepper, the sun gear, and the casing. Over here, for example, we have the top plate with the bearing already assembled, so that would be 2 out of, I think, out of quite many, I think 34 parts in this assembly. Now, for the task benchmarks, these are of course the interesting ones for the physical competition. As I said before, we would give a novel simple assembly as CAD files and assembly steps, how to assemble this piece. So it's rather sparse input, but that's where the collaboration comes in, right? So often we have, of course, the problem that assembly instructions, let's say IKEA assembly instructions or something like this, they're of course not machine readable, right? So there has to be some kind of translation into programming. So this is exactly what this task benchmark is about. Given these human readable assembly instructions and machine readable data about the pieces, how can we quickly automate most of this process? So there will be a measurement how many of the assembly steps have actually been automated successfully, and this is again something that we would score with a official next to the team, right? It's very hard to actually score this automatically. Then also the number of assembly steps that are done collaboratively. We have to see if this is a good metric, but we're open to discussion, of course, at the end. If the goal is really to automate quickly. So it might be more interesting to see how many collaborative, how much time would be spent automating a single step, right? Might be also a good metric. Then, of course, if the assembly was successful, after all, one trivial way how to do that is to just do it by hand, right? But then the other metrics wouldn't be fulfilled well. So the idea is to have as much as possible automated in the assembly steps, but to do that in a very, very quick way. So that's basically where I see the agility in our competition, right? Of course, as I said, here the rationale behind is to automate quickly. One example out of, say, the field, right, that I come across when I talk to SMEs who want to automate their production or want to use collaborative robots. Programming these solutions, of course, a very, very big cost driving factor, right? So within this task benchmark, we would also see if we can drive this cost factor down, right? How much time does it need to actually program, maybe simple, but program a product assembly process, but also how much training you have to do that, right? Of course, programming something like this quickly means you kind of have to do it without typing, right? There have to be some other way to express the dependencies between these steps. Now, for the second task benchmark, we look at the collaborative assembly as a collaborative process, right? So again, we have a similar input, description of a complex assembly, maybe novel, maybe not. This is something to describe or to define still. I would say not novel. Then there's more more time to actually describe or let's say think about how to approach this collaboratively well. And of course, we can again have the assembly instructions. And here the rationale is, in my opinion, to leverage the collaborative robot as a tool, right? Basically as a third hand, let's say, right? Of intelligent third hand. And this would, as I said before, be a complex assembly that, of course, a person can assemble themselves, but the idea would be to have this robot around to do it even quicker. And that's why time to completion is, of course, one of our metrics. And one of the other metrics we looked at was the number of assembly steps that are done collaboratively. So because we want to really drive that. Again, here, the trivial solution would be the human does it and the robot looks on. But of course, we want to avoid that, right? Again, these are some of the example assemblies. On the left, we would have a simple assembly with just 4 parts, 2 repeated ones, the gears, top and bottom plate, and they just have to be kind of stuck onto the pegs, and then the plate on top have to be clicked into the studs from the bottom plate. On the right, we see a complex assembly, as I said before, about 34 parts, with heavy repeating objects, 3 planetary dials, the nuts and bolts and so on, and very tiny bearings as well. And we have written assembly instructions. I've put some of the pages of the PDF here on screen, just to see what it would look like, right? This is something that we would then distribute along during the competition, how to do the certain steps. Looking at the example competition environment, this is kind of our, let's say, general idea how to structure this physically. On the left, we can see a hand assembly workstation out of aluminum profile bars, and on the right, this kind of our prototype for such a mobile base of a cobot arm, right? So this is something that could be docked onto the workstation and then can maybe calibrate it quickly and start working. This is something also important for the physical competition, that there is a defined time window of setup time and teardown time. So that's why it's important to also look at, as a participating team, how to set up the work area, right? Where's the tabletop, where possible collision hazards, right? So this has to be done quickly. There's this kind of gallows on top, where you can also place sensors if you like, or projectors or anything. But these, of course, have to be then put up and taken down for each iteration of the competition. This will then count also towards the setup and teardown time. So it's good to have a good package, but I would say this is quite transferable to SMEs trying to use collaborative robots for their construction, for their production as well, right? So usually in small companies, you would have, let's say, CNC machines that are programmed, put the piece in, you wait half an hour, take the piece out, you put another piece in, you wait half an hour, right? So this is a prime example for a quick automation. And this is, I think, exactly where the kind of idea comes from for task benchmark 1, right? So we want to quickly go towards a workplace and semi-automated. This is our lab environment with the build workstation on the left, where I'm sitting at. And on the right is our kind of portable collaborative robot workstation that we would, for example, we would be able to give to teams who don't have their own robot to use for the competition runs. We will, and this is what Roel mentioned as well, provide this in simulation, so you can program this robot at home, and then hopefully transfer to this kind of standard platform on site. But also we use this for our own participating team that will start now in April. We'll have 12 master students to participate in the first ADAPT competition then in early next year. And so we will really put our evaluation plan also to the test there. And of course our hardware. So this is what we have for now. We will replicate the manual workstation, maybe to have 2 or 3 of them, to have a bit more easy timetable, let's say, for the competition then. Let's hope we can actually have a physical competition in winter. But yeah, we're optimistic. Okay, so thank you. That will be all from me for the physical competition. I'm open to questions.
Hello, my name is Pascal Bettinelli from CA. I'm not sure that I well understand. You plan to have a physical competitions due to the sanitary situations. You won't have physical competitions or dry campaign.
Not right now, right? That's why we have this workshop to discuss about the setting and to kick off the Cascade competition, for which we're still processing the data. So we recorded data, but still has to be annotated. But I was talking now about the next iteration. So next winter,
okay,
right? We will have hopefully a real physical competition. But let's see how the virus mutations treat us, right?
Okay, and next year the physical competitions will take place on your premises?
Correct.
Okay, thank you.
If it's okay, I have a few questions.
Yes, please.
So do we have parts or environment color and lighting consistency in all the test environments, or like as the people who are providing the test setups and test equipment, are we obliged, for example, to provide the parts in black, or should the participants be able to detect the parts no matter the color?
That is a good question. For now, we use black because we had black material. This is, but I think so far in our data collection, that wasn't a problem. So I was surprised, but also for the RGB data, this was quite good, right? In general, I would say that it should not matter too much on the color, because we will provide the CAD models, right? So you can print this at home, for the participating teams. And of course, we will give printing instructions, so you are free to follow them. And I guess standardizing color makes sense, but I wouldn't like to define a color, because experience has shown that, of course, the color will vary in real production settings as well, right? So things will be more or less the same color. I mean, depending on what kind of quality control, of course, the suppliers do, and what kind of expectations there are.
Yeah, but like, wouldn't it be like, what if we mentioned that there can be any color, so that the participants kind of make their setups like they're like color proof somehow, or give them the ability to cover the table with whatever they want, so they have the contrast, something that they can work with. Otherwise, I think this is a point that might cause some complications with the detection.
I would be okay with saying, okay, it has to be maybe white material, right? But white on white will be difficult as well.
Yeah.
So in general, I think we either make it very colorful,
yeah,
or it will be difficult. So most likely it will be difficult. And I don't think that's a bad thing, right? So we visited a German automotive producer.
Yeah.
And they had a problem in their logistics warehouse, where they had to pick black, I think it was black plastic brake enhancers out of black plastic wrapping.
Yeah, that's the problem. Yeah.
Yeah, that's certainly a problem. Yes. So I wouldn't. I think you have a point with the color constancy. So I think one of the attachments that would probably be very encouraged to use is your own lamp, right?
Yeah.
For the robot, if you have a camera on next to the gripper.
Yeah.
Otherwise, I mean, I've seen weird constructions in industry already that, especially on top of this robot that I was describing earlier, which was supposed to pick the black thing out of black wrapping, they had a kind of a tent over it to block out sunlight, and it was still working. So I think color constancy is a big issue, but I think it would be good to keep it open to really simulate the trouble you can have with it, but be open about it, right? So
yeah, I agree. I just like I was just suggesting to give the participants a heads up.
Yes, absolutely. Yes.
I can see Yurki has questions too, but I have a couple more if it's okay. Is there I see there was some constraints on the dimensions and weight, but is there going to be a constraint on cost?
Good question. This kind of goes along your earlier question, right? I don't think so, because otherwise we would be limiting a lot of solutions, right? And how do you put a cost on something you developed yourself?
Just on the like a raw material and equipment, like, or should there be like some extra points for people who make it happen, like cheaper? You know, because these are really like not very demanding tasks. like you don't exactly need a Franca Panda to make this happen. Like you can just 3D print a robot and that can do it. And if someone can manage to do that, I think they kind of deserve more points.
That's a good question. So we haven't really discussed about, let's say, creativity points, or let's say the B rating, right? Like for grace, right? That's a good point. There's something we should maybe take into discussion for later.
Okay. And well, like just quickly, the number of sensors and number of grippers, and that's another point like we might want to discuss. And there was like also the tolerances of the parts, because people have different like printers, and well, we can discuss later other points. Thank you.
Yeah, sure. So tolerances are something, it's a difficult topic. We kind of just defined our printer as the standard, but certainly a very trivial way to do it. But yes, we should look at that. It's difficult, I think, to simulate.
Like the point arises when you want to like fit, for example, that sun gear to the stepper shaft. Like that's pretty tight fit. But for example, if we are doing a competition, I think we are better off to have it a bit loose, because we are like just to make sure that doesn't cause other complications.
Yeah. So we're on that. We are looking at optimizing these models for printing, but also for fit. Of course, for this thing to be practical, you want the fit to be tight.
Yeah.
But of course, if you want to take it off and on and assemble it many times, then the tightness right now is too much. So I agree. But it shouldn't, in general, change the assembly, right? Just tweak it a bit.
Okay. Thanks.
You're welcome.
I think Jyrki still has his hands up, or one hand actually.
Yeah, thanks, Roel. I do. So I had more of a question or a comment on the weight of the system. That if you build it on a Franca Panda, the 100 kilos max is quite okay. But if you take a Kuka Eva or something with the controller and maybe computers and stuff, it sounds that it might be a bit tight. Just more of a comment. I don't know how tightly that has been fixed yet.
Yeah, that's a good point. I was thinking of our elevators, actually. Again, practical limitation, moving them about. I have to double check on the carry capacity. I guess I would be okay with increasing that limit a bit, but that's a good point. Depending on the robot, of course, the robot itself.
Yeah.
Will use most of that budget.
Yeah, because at least some of them, they tend to weight could be over 30 kilos, and then the controller could be another 30 kilos, and then the whole frame might get a bit flimsy if you need to stick to the 100 kilos.
Correct. Yes, that's right. I actually haven't done this exercise with our setup yet, so I don't know if we actually fit into this. I would think so, but because I can more or less pick it up. So yeah, but you're right. I will double check our elevators, and maybe Roel, you can do the same to see what kind of paths you might have to take from some kind of parking to the lab, and then we can increase that. I will be fine with that.
Yes, good point. Any other open questions? If not, then I think we can move to the final presentation from Farzam. Feel free to share your screen. Just a quick introduction from your side. Welcome, Farzam Ranjbaran, who is part of CEA list. CEA, which is the French Alternative Energies and Atomic Energy Commission, which is a French public government-funded research organization. And within that list is the Laboratory for Integration of Systems and Technologies, I believe, but feel free to provide more information. Please go ahead.
Yes, good afternoon, everyone. Thank you, Roel. Thank you, Max. Thank you, everyone, with the interesting questions. Yes, I'm Farzam Ranjbaran. I'm with CEA. Unlike the other colleagues in the team, I'm quite new to both CEA and to the Metrics project. But nonetheless, it's been a real pleasure to work with the team on such an interesting competition. My background is in robotics. I studied robotics in Canada. That's in Canada and US is where I did my professional training in mostly robotics for aerospace industry. Then I moved to Europe and I've been with the European programs, and that included a stop at the European Commission for over a year and a half. And since October of last year, I've been with the CEA. So I'm a project manager here at the CEA, and I've been given the task of being the point of contact with Metrics on the ADAPT competitions. There is a research engineer who is expert in image processing and AI, Jaunari Rabarisoa, who unfortunately is not here today. So I will be making basically his presentation with a little bit of changes that I made to his slides. We're also very happy to have Pascal Bettinelli, who is our deputy head of division for the ambient intelligence division of the CEA List Institute. And Pascal is there mostly to see if on the stakeholder discussions, basically to let her have a better understanding of what the needs are, where the opportunities are, and whether from the CEA side and the connections we have with the industry, we can push things forward on that. So I'm going to present the Cascade campaigns, which are meant to be online, coming after the field campaigns, basically to let competitors showcase their capabilities in image processing and machine learning when it comes to robotics agile production. So the main features basically coming from the ADAPT evaluation plan, which you can find them on the internet, is that these campaigns are meant to be organized after the field evaluation campaigns, with the first cascade to serve as a dry run. Yes, in the current situation, the field campaigns, as were mentioned previously, have been turned into these dry runs that are ongoing now. And the data generated will be used for the cascade. Yes, the data is not very, very huge, but the features are explained a little bit. I will also show them again, the pictures. The evaluated robots annotated the detected objects with bounding box to be compared to the ground truth. Evaluation is to be done offline based on collected data sets. And the main idea for us is to ensure repeatability and fairness. And at the end of my presentation, probably it would be a good moment to also to come back to some of the questions that were raised, and Max accepted the possibilities of us looking into those more in detail, because some of these are quite important questions with possible impact on the outcomes and the added value of the competition. So Again, we have the functional benchmarks to evaluate the Cascade competitions. We have 3 of them. The first 2, the same as was mentioned before, for object detection and classification of the same components that you saw. Also to do object pose estimation and then quality control for the assembly operations, but this time on the Cascade side related to image processing and AI. So these days we are finalizing several important elements of the Cascade, and we have been delayed for various reasons, but it's going to happen anytime soon. We will finalize these questions that have to do how the data will be made available, where will it be hosted. One possibility is the Coda Lab that has been suggested recently, and we are going to make the decision very soon on that. And then the nature and the content of the data sets, the annotations, who will do them, how, and the types. So yes, I will go very, very quickly through these. You have seen them. They're the same parts that the data sets will be generated and will be made available to the competing teams. For the assembly operations. So on functional benchmarking number 1, detection and classification of parts, these you know better than me, some of the possible metrics that can be used. Again, this is only tentative list that Jaunari had prepared, and a decision is going to be made, and of course the competitors will be informed, hopefully in a timely manner, which kind of metric will be used: mean, average, precision, intersection over union. The input is a set of object classes to be detected, the instance names, descriptions, CAD models, and the images. And the output is which class, at what confidence, and about information about the bounding boxes. So the minimum time allowed per trial is 1 minute. It's foreseen to be 1 minute with 10 trials per team. And the data collection, as outlined in the evaluation plan, calls for video stream of sensor data at the rate of acquisition processing. Those are mentioned, and detected parts in the scene. 2D location plus bounding box, instance estimates at the rate of processing. For performance evaluation, the KPIs, number and percentage of correct part detection, number and percentage of correct part classifications, precision recall or F measure of detection and classification, detection time, classification time, and the level of confidence. For the second one, on pose estimation, again, these are quite known to you, but they are not finalized yet. It will be decided which one of these metrics will be used. The ones that are ambiguity invariant, the average distance or average closest point distance, version, or other means of identifying the rotation and translation, rotation metrics and translation vector of the detected pose. The input, we have the list of objects present, their names, the description, the image again, the CAD models, reference system with respect to which they are placed on top of the surface. And the output should be a 3x3 orientation matrix or rotation matrix plus a 3x1 position vector that defines the location of the rigid object. The maximum time again is 1 minute with 10 trials allowed per team. Data collection, same thing. We will have video stream of sensor data and estimated part pose in the scene with respect to the table. For the KPI performance evaluation, we have the first one is the error in the estimated pose with respect to the ground truths and the time that it takes to do the estimation. And the last functionality benchmark for the Cascade competitions is similar to the previous one, quality control of the final assembly. And here, given the image of an assembly of parts, competitors will assess the correctness and completeness of the assembly, as Max mentioned, partially assembled, incorrectly assembled, or fully assembled. Performance evaluation in the order of priorities, we have number or percentage of the correct assembly, the correctness estimate, number, percentage of correct assembly, level of completion, the precision recall or F measure of assembly correctness, and the level of completion, and the quality control in terms of the time it takes. The data to be logged are similar to with previous ones, video stream of sensor data, and estimated part pose in the scene with respect to the table. The 6-dimensional pose, instance estimates at the rate of the processing. The inputs are the set of objects or parts that are potentially included in the assembly through their descriptions or CAD models and images. A set of object assemblies which undergo the quality control, their descriptions, CAD models, images, and annotated assembly quality. And finally, the quality control metrics. A level of completion is to be estimated at a percentage or as a ratio, either complete, incomplete, or faulty. And the maximum time allowed per trial is 1 minute with 10 trials per team. The tentative schedule to be also finalized and advertised for the Cascade competition. Today is the formal launch of the process. By 15th of March, the guidelines and the details of the competition will be published. Tentatively by 1st of April, the training and validation data sets will be made available. And on the 17th of May, test data publications and opening of results submission. On the 14th of June, will mark the end of results submission. And finally, the results will be published by the end of June, on the 30th of June. Thank you very much for your attention to this presentation, which had some repetitions in it and some incomplete topics, which are going to be discussed within the next days to be finalized and bring to your attention. I stop sharing my screen.
Thank you, Farzam. Are there at this moment any questions from anyone? Yes, Max.
So I would interpret the time limit, right, as kind of a timeout, rather than expecting teams to actually take that long, right? Because depending on how you phrase it, this might be like a whole world of time, right? Or not enough to do anything, because, well, deep learning takes a long time, right? So I was wondering how you interpret the time limit in terms of the Cascade competition, if it's even relevant.
You mean in terms of benchmarking, how we measure, how we value the time that competitors take?
Right. How do you interpret in terms of the number of examples you give to be processed, right? For example.
Yes, unfortunately, that will be a question mostly to Jean-Nari, and as I mentioned, I'm presenting the slides that he prepared mostly. And but let me try to understand better, because the time sentences that I presented come from the evaluation plan, and you are suggesting that it should not be fixed.
I think
when it comes to the,
I think we have to be more precise in framing this in terms of the Cascade competition, because I think the time limit comes from practical reasons in the physical competition, just to allow, to allow enough time to do the job, right? But also have some kind of limit, so we can say, okay, you should use your next slot to go on with the competition, right? So, and this is not the same setting as in the Cascade competition, where everyone kind of works offline more, right? So there is no shared resource to use this time limit for managing, right?
Okay, so then it's quite possible that we should just for now ignore those phrases that I mentioned about the timing. And unfortunately, I cannot now give an answer.
Yeah.
How well.
One possible interpretation, of course, would be to not let the to not let the code of the participating teams run forever, right? That there will be some cutoff that, of course, 1 minute should be enough to process one frame of video, something like that, right? If it takes longer, then, well, it's not good code, so you get killed, so to say, right? To process at least. And
per trial or a collection, or the accumulated time for all of their trials, for example.
Well, that then depends on the number of examples you give them to process, right? So maybe you put to put that into relation somehow.
Yeah. Okay.
Well, it's an interesting point, actually, if you think about it from a resource point of view. In an ideal situation, or in a situation where, for example, Google would join and they provide all their clusters to do all the processing, that, well, whether or not it's a fair comparison or fair of them to join, it's would be interesting to at least mention something about it.
Yeah, good question, actually. Is this CPU minutes?
We have to think about this a bit.
Yeah.
If it's okay, I also have some questions.
Yeah, go ahead.
How many objects are we providing? Are we only providing the objects that are going to be assembly, or, for example, are we providing the data for 10 different objects and expect the robot to detect 2 out of those 10? Like, because that complicates stuff and like makes the detection job harder. Like, and how close are those objects to each other? For example, are we providing 3 different types of gears only with I don't know 2 millimeter difference in diameters, or the same size but different gears, like this kind of things?
Okay, good question. I can try to answer at least.
Yeah.
So the data sets that we have now provided, they are the easy assembly and the sort of the complex assembly. Yeah. And then the complex assembly has a bunch of additional stuff like gears and motor and bolts and nuts and such. Yeah. And these parts are all available as 3D printable CAD models. And it should be quite possible for teams to get the additional parts. They're quite standard, like bolts and things like that. And we provide a data set, but we do not limit, of course, that people make their own data set. And there's CAD models, so you can also generate digitally a data set. So in that sense, we leave it open how innovative people develop their solutions.
Yeah, I think there is a part I don't understand. Like, are the teams to train the models on site, or do they have the time to do it on their own and bring the trained models?
So if we talk about the Cascade competition, this is sort of a competition that runs for 1 month, 1.5 months. It's not clear completely. And within that time frame, they have the data that we provide, and they can generate their own data themselves. Right?
Okay.
Then for the field competition, well, I think for the first time, the parts will be the same, and this data is already available, and we are now in the process of generating the data set that will be used in that field competition. And then still, teams can generate more data if they want to. Then when the competition happens on the spot, then it's quite unlikely, I think, that they would still do training, but they can, of course, because teams would travel and they don't stay for 3 weeks. But you can, of course, use 1 day to train things, but maybe the fine-tuning is not enough. So I think it's more about the evaluation than about the development at that point.
Okay. One more question. We have the ground truth about the position and orientation of the parts. That is how we evaluate the accuracy of the measurements by the teams, like the pose estimations. Yeah, but my question is like mainly out of curiosity. How do we obtain this ground truth? How do we measure it?
From the organizer point of view, I would leave that gracefully open. I think there are a couple of ways to achieve that. I was even thinking of, printing a whole assortment printing a complete model of the parts at certain locations, right? And then you just have to reference that base model, basically, right? That would be one way to do it. We are looking also at ways to calibrate the poses of the objects with an external device, right? So there will be ground truth data, but participants shouldn't know. Well, they should know about it anyways because they will just report the ground truth data. But I think it's irrelevant where they come from. But we'll find ways.
Okay. So let me get see if I understood correctly. So one way is to print the parts somehow welded to the like some sort of a saddle.
That would be one way to do it, for example.
Okay, but that kind of limits us to a very small area. Like if we wanted to post images which are, let's say, in a square of 50 centimeters by 50 centimeters, then that we don't have many printers that can do that big.
Well, it all depends on the time you want to spend on it, right? So we do have a printer that with one of those unlimited Z-axes.
Yeah.
We can print long slabs.
Okay.
So that would be one way to do it. Otherwise, we can of course have a pre-calibrated kind of raster where to put the objects, right? Or this little prefabs. I mean, there are lots of ways to do it.
Okay.
The great thing about the kind of in-person competition is, of course, it's much slower than the very scalable Cascade competition, right? So in the Cascade, everything has to be done beforehand. The ground truth data has to be somewhere hidden on the server, where it can be evaluated, right, against the participant input, but it's kind of that's it. But for the physical competition, I tried to say this a bit in my talk, we have the advantage that there is a kind of resource constraint on the performance of the tasks, right? And when we ask the participants to also give data about the movement of their kinematic structures, we have kind of a way to calibrate that already kind of within the volume. So we can talk about detections and placements and so on, not on a frame by frame basis, but on a shared coordinate system basis, right? So that would be a multiplicator to actually do this also by hand, for example, kind of on the side in the physical competition. It's of course not a great job, something that maybe our student assistants can do on the side, and then we have very good ground truth data from that.
Okay, I have another question, if that's all right. One way is that we receive the answers and then compare it to the ground truth, and that's how we evaluate. And the other way is to get the code from the participants and run it on our own, and then that's how we evaluate it. The former kind of opens the door to some sort of cheating, like if the ground truth somehow leaks somewhere. But the second is like if the participants are not very protective about their work, it also opens the door to evaluate the performance because we get the chance to run it on a standardized hardware. So then the speed.
So you're talking about the Cascade competition, right?
Yes.
So we talked about this a little bit in a previous meeting, and I understood that it's going to be difficult to actually accommodate everybody's code environment, right? You could say, okay, we'll just make people submit Docker containers or something like this. But that also often requires a certain hardware, then you have to bundle the drivers and so on. Maybe you don't have to write NVIDIA or whatever other card, right? So that's a big hassle to actually practically perform this, right? So we were thinking to give a small time window between publishing the competition test data and asking for the estimations on this competition test data. Just to compress that a bit and let everybody run their own. And I mean, who would be stupid enough to submit ground truth results? Nobody gets 100% on anything, right? So that's something to check for.
That's easily managed. Like you can just add and like subtract a bit from here and a bit from there. Nobody is that stupid. But still, the door to that kind of cheating is open. But regarding the hardware and the environment, as far as I know, most people use Python, and they're like the image processing unit, image processing libraries are like there are like quite popular ones. Of course, like with this approach, and this is like kind of we close the creativity on some people who want to do that, to do different approaches and maybe come up with their own code instead of using like ready-made modules. But I'm not a professional programmer, but maybe we can find a way to standardize their code. Maybe they can provide some sort of an exe file or a executable in some other form. And then we also can say, okay, here's the thing, we have this CPU, we have like, for example, this GPU, and make it happen with that. This is just, for me, this is just my opinion. It makes it more interesting to add that kind of constraint. Plus, it kind of eliminates the people who have access to really expensive, for example, Tesla GPUs, and you know, like.
But you wouldn't train on the. I mean, we wouldn't allow participants to train on our hardware, right? They would send pre-trained models. So then again, you have this disparity. That maybe some people have, I don't know, good connection to Amazon and can use their GPUs for free or something like that. And there you have it. Right.
Okay, that's another thing. Like we can also have them train our own GPU.
This is
that's
getting
a lot of work.
Yeah, this is. I mean, it becomes a resource problem at some point, right?
Mm-hmm. Yeah, well, we can have these batch runs, but yeah.
Well, with respect to the resources for training, I would not put so many limits on that, because if even like it is very easy nowadays to get resources. I mean, universities, they provide for students just access to their clusters, and that's would be a pity if we would do that. But
yeah.
But yeah, very good questions. I think we have still some additional discussions to be made.
Okay.
Did you have more questions?
I always have more questions, but no, I'm done for today.
Okay. Okay. Thank you.
Thank you.
All right. Well, I think we are somewhat officially now to the open discussion part. Let me first start that if at this point we run a bit over time, feel free for people that have a next meeting to disappear. I don't want to limit anyone's next appointments or their weekends. But the first thing that I would want to do actually is to guide the discussion a bit towards SMEs and stakeholders. And Jyrki, I hope you are still around. I invited Jyrki today because he is both chairman, I think, of the Robotics Society in Finland, and you have also a big role in Digital Innovation Hub Trinity that connects SMEs to innovation. So based on what you saw today, I would like to hear your thoughts, what companies would think about these kind of challenges.
Yeah, thanks, Roel. I think from my point of view, it looks quite good and something sort of like simple and understandable enough for the SMEs. So the tasks are quite clear, and I think you can quite easily see that how could you implement these kind of development in machine tending or assembly or something like that. So what I would be sort of interested to see is how to engage them, especially the ones who have some technologies to provide maybe as a challenge or to be used in a challenge for this competition. So I think that's something that definitely we can link with the Trinity demonstrators, because there are some companies providing these technologies, and also there are couple of companies in Finland who arrange their own challenges for students in the nearby universities of applied sciences. So I think they might very well be interested in taking part somehow. So I think we need an effective marketing campaign to get them involved without sort of requiring too much. But I think all in all, what I heard, it sounded like quite okay.
Mm-hmm. Thank you. Yeah, I think it would be very interesting actually if we could get a real problem from an industrial company or an SME. Of course, there's a lot of limitations that could be there, that they don't want to open up their problems maybe, but something we should pursue, I think. Perhaps it would be also interesting to hear CEA's point of view of this. Pascal, are you still connected?
Yes, I am still connected. If I well understand, there is a different kind of stakeholders, and one kind is the people that will be engaged in the competition, and that is your first concern.
Well, yes, the first step, of course, is to find the right people and to try to get them either participate or known about this competition, and have them either provide sponsorship or problems, or just make them known that this exists. So there's many different ways they could participate, of course.
Yes, because regarding people that can be involved in the competitions, I think we can try to have some contact with a company that work in this field. Just to be sure, you can do only Cascade campaign without doing the field campaign. That's true.
Yes,
Okay.
they're not connected. Well, they are linked, of course, but there's no limitations on teams that have to participate in both. You can choose one and the other, or both. Yes. And I mean, I can imagine that for some companies, the Cascade is more important or more of interest, and for others, it's more about physical interaction with a robot. So it's different.
It's just because if the only place where we can do a physical campaign is in very far from France, it can be quite difficult for SME to spend time to go here. So I think it can be something difficult for them to find money, to find time, and to travel. So it's why I ask you the questions. We will work with Farzam to get in contact with some of them, and we will also have a look to the university if some of them can be interesting to participate in the campaign. My second question is regarding a sponsor. What is not clear is what they can get if they sponsor something in the challenge. At the beginning, you explained that there is different kind of sponsoring. You can sponsor a team, if I well understand, and in this case, it's only, I imagine, I don't know, perhaps you will explain me something else. It's only a relationship between the team and the sponsor, and it's all. But if you are looking for a sponsor for the competitions, if I read your website, I see that they can have the logo, for instance, but perhaps they want to have more input, because, for instance, if we ask a robot manufacturer to be a sponsor, and the competition is done with a Franca or with another kind of robots, it can be perhaps something difficult for them to understand.
Yes. Yes, you're correct. It's I mean, there exists a document that has some specifications on how a sponsorship could work, in what form, and what you get back for it. But in my feeling is that I mean, it's of course a bit tricky for a company to just say, okay, I pick this kind of sponsorship and this is what I get back. They of course have their own plans and initiatives and things that they would like. So it's more of a discussion point to have with a company to see how they can contribute and what they could get back of it. And it's not something that we should put in boxes, I believe. So if there would be companies interested, then that's more of a discussion than telling them that this is what you get and this is what we receive.
Okay. So what you want is that we identify a sponsor, and what you expect with in-kind. What kind of in-kind it can be? For example, they can share a robot for the field competitions or things like that. What are you expected?
Yeah, for example, I mean, I have no good view of what companies could offer, but that would be one option, of course. Yes. I don't know, Max, if you have some viewpoint from Germany.
Yeah, so we also talked about prize money, right? That could be donated. So that would make it difficult for consortium partners to participate in the competitions. I think that would probably look weird if we give ourselves the prize money in the end. I think, so as an example of a sponsorship with hardware, so in the European Robotics League, PAL Robotics gave out Tiago service robots as kind of like a competition in itself. So you had to write some proposal, basically what you want to do with it, and then some teams won this platform as a loan, I think, for a couple of years. And this is also an open hardware competition. So this was a way for PAL to make their robots known, right? And hopefully they give it to the best teams, so the best teams win, so their robot wins, right? That would be also possibly one way how a robot manufacturer could give in-kind contributions to participating teams, right? Also in our case.
Mm-hmm. Yeah, I think there's different kind of options that are possible. Is there any other burning questions from anyone else on this stakeholder?
Yeah, if I may.
Yes.
Go ahead, Pascal.
Sorry. Yes, last questions, because what another type of sponsor that you are speaking at the beginning is, for instance, end user, a manufacturer or something like that. You are interested by this kind of sponsor. That's true. Okay, and but if they want to get access at the end of the result of the different technology that will be used during the competitions, they have to pay a large amount of money for the sponsoring.
Well, again, it's a discussion, I guess. Obviously, we would like to be as open as possible. So whatever results from this project that are made, they should be open. So it might be a bit tricky that if we say that there's a company that comes and sponsors a benchmark, that we only get the results to that company. So that's probably not something that is possible. But I can imagine that they could be, for instance, they could get a first look to the results, or they could get access to the people that develop them. So there's of course other things that we can offer that is useful for them. But it's the SME probably that has to tell what they would want to get out of it.
Yes, I agree that probably access to talent who have then a proven track record in exactly the kind of problems that a certain manufacturer has would probably be the most valuable, right? Basically a recruitment tool maybe for the manufacturing SMEs, or maybe they can also be large companies, right? One other stream of new recruits, maybe. And by putting out the challenge themselves, they would kind of steer the experience that people get from it, right? To be more compatible with what they're actually looking for.
Can I have a question? How open are we about this sponsor for the prize money? Like, does it have to be some industrial company, or like, for example, people who are in education business? Are we open to those as well?
Anyone who wants to give money?
Yes, I have been there are a few that I have in my mind. I just opened some tabs, so I know which one is it. I remember the names. They want, given the amount of advertisement that I see them like do through different channels, I see they want to be seen. And for example, like there is this Brilliant, the website brilliant.org. They have like different level interactive lessons, and they also have lessons about AI, artificial intelligence. Okay, and that's one of the topics people who want to participate will need to learn. They would want to be like visible on such competitions. I think it is worth trying to gain their attention and present them with the amount of publicity and the kind of publicity they would gain by being named there.
Mm-hmm. Yeah, that's a good point.
I think we also have to think a little bit about multiplicator events that we would present metrics and this competition at. And then this would be a vehicle for publicity for the sponsors as well, right? Not only on the website, not only at the events that we host ourselves, but also those multiplicator events that we go to. One of them, of course, being ERF, but other ones, for example, the ones that you keep posted in the chat, would also be useful, right? To kind of capitalize on this European connectedness that we have in the project, to use that as a multiplicator for their brand recognition, for example. It's not what I'm trying to say. It's not only to be kind of represented within the people who have immediately something to do with the competition.
Mm-hmm.
Roel, sorry, I had some of the similar questions that were asked, but in terms of the future years of the challenges, something I don't know, and I should know, sorry, are we going to repeat the same scenarios, or is there room for modifications and new ones to come? You mentioned briefly new benchmarks to be probably proposed by or larger enterprises or SMEs, depending on how much they sponsor. But imagining someone with a real case from industry and with real good motivation and sponsorship package, can we go in the direction of letting them define or co-define, let's say, for the last year? Yeah, challenge.
Yes, we would really like that. I think it would be very nice. We provide now sort of a benchmark, I guess you can call it, for the benchmarks, and they will get tested, and we will see how hard they are. So I expect that next year they will be different, they will be adapted, and there could be new ones. Yeah. Ideally from externals, yes.
Okay, great. So along that line, to you and to Max also, because the way I have learned, and I'm still learning the business here, we are doing competitions that is somehow combining capabilities in robotics, collaborative robotics in particular, which on its own is a very important and complicated challenge with AI and machine learning and vision processing, and they are quite entangled in a way that we cannot really say at which point is it the task benchmarks that are really doing the robotics side, and then the Cascade doing the rest. That's within this ambiguity that I have from understanding the situation now. Then the notion of collaboration, collaborative robotics, where does it start? Where does it end? In other words, what would be a fantastic collaborative system and what would be non-collaborative? I can imagine what it is. But maybe there are also areas that in that more clarification of what would be really a robotic challenge and evaluation and what would be the rest and how they connect. Of course, they are there now, but to me, they don't become very clear. As one of the organizers, I must
Yes. Yes, I mean, it's that's the good thing is that we are doing this now as a dry run. So there's only lessons to be learned here. And we will, of course, try to improve over the years to get this in a better shape.
But you confirmed that it is possible. So as we, with Pascal and colleagues, we do a sort of a campaign in France, hopefully, well, try to get some interested stakeholders involved. If it is done in a timely manner and early enough, there will be a possibility that they get involved in the discussions and propose something. And then I imagine we need to sort of design a mechanism that would say by this time, new suggestions would be, as a concept level, would be welcome. At this time, we will finalize them. And there's work for us to do, I think.
Yeah, that is correct.
I would support that there would be kind of a process to it. Because I think there is a value in, let's say, a more independent evaluation. I'm not sure how to call it, entity, right? As the metrics project. And I think it's valuable enough to protect it a bit from too much interference, right? So there absolutely has to be a process, and it should be transparent.
Absolutely, yeah. If it's transparent and if it welcomes and absorbs really interesting and good ideas, that would be fantastic. Yeah.
Yeah.
Okay.
All right. I think we've been discussing now for more than 2 hours. I don't want to start asking more questions unless anyone else comes with one.
And I have one more comment to Farzam's question about what is collaboration. This is, I think, also an open question scientifically, right? Because it's on one hand it's a definition, on the other hand,
it happens in
Exactly, it's a process, right? And I'm not sure. I think the ambiguity is also by design, right? That we don't want to restrain the kind of interpretations of collaboration that participants might have. So I think one thing that we should keep in mind is that, of course, it's an open call for participation, right? Personally, I think it's more of a continuum of what is really collaborative. Maybe you can be more or less collaborative, right? So I think this is also maybe an interesting thing to modulate within the process of actually assembling something in a collaborative way. Maybe some steps need to be more collaborative, some less, right? So I think this is by design. So I think it's completely fine to be not clear on that. That's what I'm trying to say.
Yes, I agree. Okay.
Okay.
Maybe perhaps this is a good time to close the meeting. Am I too pushy?
No, it's good.
Great.
All right. I want to thank everyone for joining and for participating. and to be continued. We will probably soon enough follow up with publishing all the information about the Cascade campaign and starting that.
Okay.
So thank you everyone for joining.
Thank you for arranging.
Thank you for sharing the information.
Thank you.
Bye.
Okay. Bye.
Thank you.
Bye-bye.
Thanks. Bye-bye.
Bye-bye. Bye.
See ya.